In the vast tapestry of mathematics, two remarkable ideas, pi and the Fibonacci sequence, emerge as legendary symbols that capture our imagination and spark curiosity across generations. Today, we embark on a journey that explores how these seemingly distinct concepts intersect in unexpected ways, shedding light on their roles in both the natural world and the underlying structure of our universe. Imagine a bridge between the smooth curves of circles and the enchanting spirals found in sunflowers, seashells, and even galaxies. That bridge is built from the constant beauty of pi and the recursive charm of Fibonacci numbers. In this exploration, we delve into the geometric elegance of pi, unveiling its profound connection to circles, waves, and oscillations in our everyday existence. We then reveal the magic of the Fibonacci sequence, a series that not only dictates growth in nature, but also creates a blueprint for some of the most captivating patterns in art and science. As we traverse through the realms of classical geometry and quantum mysteries, we encounter a cosmic dance where these concepts intertwine gracefully, hinting that they might have been present from the very inception of the cosmos. Our discussion is designed to be clear, relatable, and inspiring, inviting you to see mathematics in a fresh light. Every curve, spiral, and fractal structure you observe in nature may be echoing the timeless formulas that underpin the universe. So sit tight as we unravel the story of pi and Fibonacci, two pillars of mathematical wonder that guide us from the microscopic quantum world to the expansive universe. Let's uncover how these patterns not only decorate nature, but also whisper secrets about the origins of everything. Embark on this narrative as we illuminate the connections between timeless formulas and the dynamic beauty of the world around us. Join us now. Pi is one of mathematics' most celebrated constants, and its story is as captivating as the mysteries of nature. Defined as the ratio of a circle's circumference to its diameter, pi is an irrational number that never ends or repeats. Its infinite, non-repeating decimal expansion, 3.14159 and beyond, provides a window into the eternal beauty of mathematics. From ancient civilizations to modern technology, societies have marveled at pi's consistency in describing the curves of circles and spheres. From ancient civilizations to modern technology, societies have marveled at pi's consistency in describing the curves of circles and spheres. The pursuit of calculating pi has journeyed through centuries. Ancient mathematicians from Babylon, Egypt, and Greece used creative geometric methods to approximate pi. Their ingenious methods, such as inscribing polygons within circles, laid the foundation for the precise calculations that we enjoy today. With the advent of computers, pi has been computed to trillions of digits, yet its true form remains forever elusive, an endless string of numbers that defy simple pattern. Pi is not only a staple in pure mathematics, it also plays a crucial role in the natural world. Whether it is the sound waves vibrating in your favorite song, the orbit of planets around the sun, or the life-sustaining cycles in nature, pi is there underpinning the geometry that shapes reality. The constant appears elegantly in formulas for the area, a equals pi r squared, and the circumference, c equals 2 pi r of circles, in the volume formulas for cylinders and spheres, and even in the wave functions that describe quantum behaviors. This ubiquitous constant also finds a place in creative fields. Artists, architects, and engineers embrace pi as a symbol of perfection and beauty in design. The curves it defines are integral to creating structures that are both aesthetically pleasing and functionally robust. In many ways, pi is the silent rhythm that guides both the natural and engineered worlds, offering an everlasting reminder of the harmony that underpins all things in our universe. Pi's influence extends far beyond the realm of numbers. It is a testament to the interconnectedness of the universe. At the heart of nature lies a sequence that is as mysterious as it is mesmerizing, the Fibonacci sequence. This series begins simply, 0, 1, and each subsequent number is the sum of the two preceding ones. Over time, the sequence evolves into an endless pattern that has captured the fascination of mathematicians and nature enthusiasts alike. Its simplicity gives rise to complex and beautiful structures that are visible in the spiral arrangements of seeds, shells, and even galaxies. The magic of the Fibonacci sequence extends to its intriguing relationship with the golden ratio, phi, approximately 1.618. As the numbers in the Fibonacci series grow, The ratio of consecutive terms converges towards the golden ratio, a constant that appears in various domains from art and architecture to the most efficient natural growth patterns. This golden number is celebrated for its aesthetic appeal and is thought to encapsulate the ideal proportions found throughout nature. The sequence and the golden ratio work together to create a harmonious balance, offering a blueprint for growth that is both mathematically precise and visually appealing. When you observe a sunflower, you see petals arranged in spirals that reflect the Fibonacci pattern, maximizing exposure to sunlight and optimizing space. Similarly, the spirals in a pine cone or the delicate curves of a seashell all disclose the underlying Fibonacci magic. This recursive pattern demonstrates how nature utilizes simple rules to create intricate designs that are both efficient and resilient. Beyond natural observations, the Fibonacci sequence inspires creativity in human endeavors. Architects, designers, and artists have long employed these principles to achieve balance and beauty in their work. Whether in the layout of a building or the composition of a painting, the Fibonacci sequence provides a subtle yet powerful guideline for achieving aesthetically pleasing forms. Overall, the Fibonacci sequence is more than a list of numbers. It is a window into the organic and harmonious processes that shape the world around us. One might wonder how two distinct mathematical entities, pi and the Fibonacci sequence, can come together to create something truly spectacular. The answer lies in geometrical patterns, where the elegance of circular arcs meets the beauty of recursive growth. A perfect example is the Fibonacci spiral, built by drawing circular arcs with radii that follow successive Fibonacci numbers. Each quarter circle, spanning precisely pi2 radians, blends the predictable nature of circle geometry with the dynamic progression of the Fibonacci sequence. When we look at a Fibonacci spiral closely, we see that every segment of the curve is a harmonious blend of measurement and growth. Pi provides the measure of the circular arc, its constant presence ensuring that every twist and turn follows a precise geometric form. Meanwhile, Fibonacci numbers determine how large each arc becomes, following a pattern that seems to capture the essence of natural expansion. This relationship is not merely coincidental. It is an expression of the universal language of mathematics, where constant ratios and recursive sequences work together to shape the structures we see in art, architecture, and nature. The golden spiral, which closely approximates the Fibonacci spiral, exemplifies this interplay even further. As the Fibonacci sequence progresses, the ratio between successive numbers converges on the golden ratio, a symbol of aesthetic perfection. Artists and architects have long incorporated this golden ratio into their designs, consciously or unconsciously, using it to create compositions that are balanced and pleasing to the eye. In natural phenomena, from the arrangement of seeds in a sunflower to the swirling paths of hurricanes, the golden spiral echoes the deep-seated principles that govern growth and form. Moreover, this blend of pi and Fibonacci in spirals serves as a powerful metaphor for the interconnectedness of all things in the universe. The same elegant curves that govern the orbit of planets and the flow of time also dictate the unpredictable beauty of a blooming flower. This synthesis of mathematics and the natural world invites us to see the universe as a grand mosaic, where every element, from the smallest petal to celestial bodies, plays a part in a unified design. In exploring these geometrical patterns, we also discover the profound impact of symmetry and recursion. Recursion, the process of repeating a set of rules over and over, forms the backbone of both the Fibonacci sequence and the construction of circular arcs defined by pi. This repetition gives rise to fractals, self-similar patterns abundantly found in nature, where the branching of trees and the intricate network of veins in a leaf echo the interplay between a fixed constant and a dynamic sequence. Ultimately, the merging of pi and the Fibonacci sequence in geometrical patterns is a celebration of growth, continuity, and beauty. It reinforces the idea that mathematics is the foundation upon which the universe is built. It reminds us that the universe is not built on isolated concepts, but on a symphony of relationships that create the intricate tapestry of life. Together, pi and Fibonacci orchestrate a mesmerizing duet that echoes through every natural creation and inspires our continuous quest for understanding, truly profound. At the quantum and subatomic level, the interplay between Pi and Fibonacci-like patterns takes on a new dimension of intrigue. Although quantum mechanics is governed by principles that often seem counterintuitive, the same mathematical constants that guide classical geometry find echoes in the strange fabric of the microscopic world. In equations describing wave functions, interference, and uncertainty, Pi appears as an indispensable constant, ensuring that even the most unpredictable systems adhere to a fundamental geometric order. Surprisingly, theoretical models have begun to uncover hints of Fibonacci patterns or similar recursive sequences within quantum systems. Some theories in quantum field dynamics and particle arrangements propose that self-similar growth, reminiscent of the Fibonacci sequence, may govern the distribution of energy levels or the fractal nature of quantum states. These explorations suggest that the golden ratio, arising from Fibonacci's progression, could subtly influence the symmetries observed in subatomic particles and even in the fabric of spacetime. Moreover, the connection between Pi and quantum phenomena is exemplified by the periodicity found in quantum oscillations and the probabilistic waves that define a particle's existence. In these realms, geometry is not merely confined to smooth circles or spirals. It extends into abstract spaces where state functions and fields exhibit intricate patterns. Whether through the normalization of wave functions or via Fourier transforms, Pi is an integral part of the language used to describe the quantum world. When viewed from the perspective of quantum geometry, the Fibonacci sequence transforms from a simple list of numbers into a metaphor for the universe's inherent recursion and self-organization. This mysterious convergence of mathematical themes at the smallest scales challenges our conventional understanding and hints that the same principles shaping galaxies also influence the tiniest particles. In this light, Pi and Fibonacci are not isolated entities, but are intertwined threads in the fabric of reality, weaving together order and chaos in a cosmic dance. At the Planck scale, where the fabric of spacetime is woven from the tiniest threads, both Pi and Fibonacci emerge as fundamental components of the universe's blueprint. The Planck length, an almost unimaginably small measure, represents the quantum realm where classical physics merges with quantum phenomena. Here, Pi remains a steadfast constant, appearing in the equations that describe the curvature of space and the vibrations of particles. In this extreme environment, even the geometry of the cosmos conforms to patterns that echo both circular perfection and recursive growth. Emerging theories in quantum gravity and string theory suggest that spacetime may be discretized into tiny quanta that resonate with the patterns observed in both Pi and the Fibonacci sequence. Some models even propose that the self-similar, fractal nature of the universe at this scale mirrors the eternal recurrence found in these mathematical constructs. Whether it is through the normalization of quantum fields or the modeling of cosmic inflation, the influence of Pi and Fibonacci hints at a deeply ordered structure underneath the randomness of the Big Bang. Moreover, the idea that these constants were present from the very beginning introduces a poetic narrative, that the universe was designed or naturally evolved with an intrinsic mathematical harmony. From the swirling dance of subatomic particles to the vast expanses of interstellar space, the fingerprints of Pi and Fibonacci's legacy are evident. Thus, at the most fundamental level, the enduring presence of Pi and the Fibonacci sequence serves as a cosmic signature, encasing the universe in a framework of order, beauty, and timeless mystery. These constants remind us that the fabric of our cosmos is woven with patterns profound and eternal. Pi and the Fibonacci sequence are not merely abstract concepts, but profound elements woven into the very fabric of our existence. Their appearance in both the minute quantum realm and the magnificent cosmos hints at a universal order that transcends human understanding. Whether one views these mathematical wonders as evidence of a deliberate design or as the inevitable outcome of natural laws, their impact is undeniable. They form a common thread linking the evolution of matter, the architecture of nature, and the beauty of art and design. This convergence inspires a sense of wonder and invites us to explore the deeper questions of our origins. By studying these universal patterns, we gain insights into the hidden symmetries that govern our world. Ultimately, the interplay of Pi and Fibonacci reminds us that, in the end, Beauty and order emerge from the simplest rules, a realization that is as philosophically profound as it is scientifically intriguing. In this light, the universe itself appears not as a chaotic accident, but as a masterpiece of harmonious design.